Hello, and welcome back to another part of the review for the Math 201 Statistics Final. And we're going to work on a couple problems in this lesson, starting with problem number 5. It says, at Burnt Mesa Pueblo, the method of tree ring dating gave the following dates AD for an archaeological excavation site. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data in our sample. And you're probably wondering like why they're giving us the normal plot. The normal plot, remember that this probability plot is linear, and so it shows that it's normal, so that's good. They didn't ask us to verify the requirements, but it's good to see that. And it looks like the data is a little bit skewed, but that's not a problem either. So it says, construct a 90% confidence interval for the true mean of all ring dates from this archaeological site. So formula substitutions and answer. So our formula for confidence interval is in our formula packet. It's X bar plus or minus T, because we have means data. And so we're using the T distribution. And so it's T of alpha divided by 2 because it's a confidence interval. And then we're going to multiply that by the standard deviation divided by the square root of n. And they wanted a 90% confidence interval. So that means alpha is 1 minus 0.90, which is 0.10. So alpha divided by 2 is 0.10 divided by 2, or 0.05. So we need T of 0.05, and our degrees of freedom is equal to 8. Because n is 9, and so degrees of freedom is n minus 1. So we're going to go to our Desmos here. And I wanted to put in the data. So I've listed my data here, and I have the mean at 1265.67. And the standard deviation at 42.053 divided by the square root of 9. And so I calculated my margin of error, and I added it because I just want to verify. I did it by hand, but I want to just verify for when I get my the means program. I'm going to use that actually. And so whenever you have raw data, we did have to put that data in a list, and then we calculated the mean and standard deviation to use in the program. So I'm going to the means program, and I put in the mean 1265.67, my sample size of 9, and then the sample standard deviation of 42.05. Currently, we're not doing a hypothesis test, but we are doing a confidence interval, so we have to put in our alpha. And we said alpha was 0.10. And then I am just choosing the drop down for the confidence interval. And there is my lower boundary, which is 1239.61 when you round, and the upper is 1291.73. Now it's maybe off just a little bit from the answer key, and that's okay as well. And that's just because of, if you look at where I did it by hand in the Desmos file, that was a little bit closer to what maybe if the answer key was off a little. So let's go back to our paper here. So letter B says, does the confidence interval found above contain the true average tree ring date for the site? Not necessarily. It could. We're 90% confident that it does, but we don't know for sure. And then it says the confidence interval size would blank if the confidence level was lowered. So if we lower the confidence level, we decrease the interval size. And then D says the confidence interval size would blank if the sample size was raised. Circle 1. And so if we increase sample size, that's increasing the denominator, which makes your fraction get smaller, which makes your margin of error get smaller. And so that is also decreasing our sample confidence interval. And E says, explain why it is important that you be given a normal probability plot and box plot for this data. And that's because our sample size is so small. And then F says, construct a 90% confidence interval for the true standard deviation of all ring dates from the archaeological site. Oh, for the true standard deviation, we're going to delete that. We did not do any confidence intervals for standard deviation. So you can just delete that letter F. I did not give you the critical T value though for the confidence interval. So let's just go back and check that out. And that is in here. So our T was degrees of freedom was 8, and our alpha divided by 2 is 0.05. So right here. So our critical T was 1.86. Wrote that in here, 1.86. And right here, 1.86. And so here's our final interval. So let's look at question number 6. Question number 6 says, in normal seasons, the average tobacco production of large Cuban tobacco growers is 1,000 bushels. After a cool season, agricultural officials are predicting a bumper crop of more than usual bushels. State the hypothesis symbolically. So it says state the hypothesis symbolically. So HO and HA. And it looks like they're talking about is 100, 1,000, and it's bushels. So that's units. So we're talking about the mean. So they think it's 1,000. And then they're kind of thinking there's going to be a bumper crop of more than usual. So they're thinking it's going to actually be bigger than 1,000 this time. Is this a right-tailed, left-tailed, or two-tailed? It's right-tailed because it's pointing to the right, our inequality. And then it says, suppose a random sample of 51 Cuban tobacco producers had a mean of 1,105 bushels. A researcher conducts a test and finds a p-value of 0.075. Are these findings significant at the 0.05 level? So that means that we already have the p-value, so we can just compare the p-value to the alpha. And they said, let alpha be your level of significance. And the p-value is 0.075, which is greater than. So we do not reject H0. So there is not significant findings. It is bigger than the 1,000, but it wasn't significantly bigger. And then it says, what would it mean to make a type 2 error in the context of this situation? So type 2 is do not reject H0, but the crop actually was significantly larger. So even though we did not reject H0 with our evidence, we could be making a type 2 error if in fact somehow our sample wasn't good evidence and we really should have rejected. And then letter E says, is it sensible or possible to lower the probability of making a type 2 error to 0? Explain. And it's not possible to eliminate all error. And they're pretty low anyway, but it's not possible. Let's look at example 7 next. It says a researcher conducts a study on people who were abused as a child and whether or not they later commit a violent crime. The sample data obtained by the researcher are summarized in the following table with some spots left blank. So along the vertical over here, we have they committed a violent crime or did not commit a violent crime. And then the columns are the people that were abused as children, and then the control group of people that were not abused. So I'm going to go ahead and get my column totals. So that's going to be 908 and 667. And then my row total is going to be 155 and 1420. And so my rows total to be 1575, and my columns also total to be 1575. Okay, so that's A. Find the totals and write them in the table above. B says, how many had committed a violent crime? How many committed a total violent crime? 155. How many people had been abused as children? So that's the total abuse, 908. How many people were sampled altogether? 1575, 1,575. What proportion had been abused as children and committed a violent crime? So they were abused as children, so that's this column, and they committed a violent crime. So it's just that little bit of an overlap of 102 people. So that is 102, and they want a proportion, so it's out of the total number of people surveyed, 1,575. And that comes out to be 0.0648. That says if a random subject is selected, what is the probability that they had been abused as a child or committed a violent crime? So the probability of abused or probability of committed violent crime. So let's look here. They were abused is the column values, and committed a violent crime are the horizontal. And because there's overlap, we have to take that into account. So that means we're going to take the abused of 908 plus those that committed the violent crime, which is 155. And then we're going to subtract the overlap. And the overlap is that 102 from above here, because they were abused and committed a violent crime. So let's go ahead to Desmos. And this is 7. Okay, so that means we have 908 plus 155 minus 102. And then we're going to divide that out of the 1575. And so that comes out to be 0.6102 for number 7. And he says, is this an example of an observational study or designed experiment? And this is observational. And that's because to be a design experiment, we would have to be controlling, we would have to be randomly putting people into groups and deciding if they were going to be abuse victims or not, and if they were going to commit violent crimes or not. And that is not ethical. So observation because we cannot ethically force people to be abused or commit crimes. That is question number 11. So catch me back for another review video.